Welcome. I'm Mallory Allison, Editor-in-Chief of Cambridge Health Tech Institute's Pharma Week and Biomarker Breakthroughs e-newsletters. Our topic today is cell therapy, and I'm joined by Sarah Ferber, Director of Molecular Endocrinology at the Sheba Medical Center and Diabetes Research Institute. Sarah, would you like to tell us a little bit about your area of interest in terms of this type of work?
Yeah, our area of interest is cell replacement therapy for diabetes. There is a shortage in tissue availability for treating diabetic patients. So we were looking into generating autologous cell replacement therapy for diabetes.
And you have a very unusual approach. Can you explain a little bit more about that?
Yeah, our approach was to use our own mature organ to generate tissues in need. And at this point, what we are using is liver. The liver of diabetic patients is meant to be transdifferentiated or redirected towards the pancreatic lineage so that liver cells will lose their original developmental fate and function and acquire a new developmental fate and function of insulin-producing cell in the pancreas.
What did you need to know in order to make this happen, and where have you successfully made it happen, and what types of models?
So the idea was that if we know what transcription factors control pancreas organogenesis in the embryo, we could force the expression of these factors in other adult organs and analyze whether these factors are sufficient to activate the pancreatic lineage and function in adult tissues. This is something that nobody else before thought of looking into it, and it proved.
And you said you've achieved this in animal models and in cell culture, in human cell culture. Is that correct? And has your work been replicated?
Yes, actually, our work is replicated and enlarged by additional groups now, and it's an ongoing research. And I would say that at least 10 groups are now doing it, if not more.
So you mentioned that you had a paper published yesterday, and that has some remarkable insights about what's actually taking place when these liver cells turn into pancreatic cells. So what have we learned?
So our original publication started back in the year 2000, showing that you can convert liver to pancreas, and it was published in Nature Medicine. Afterwards, we looked into human tissues, and we showed that whatever goes in mice actually works also for human liver tissues. And what came out yesterday in the hepatology paper is the mechanism, how this happens. So the transcription factors, the pancreatic transcription factor that activate the pancreatic lineage and function in liver is also an hepatic dedifferentiation factor. So first it induces hepatic dedifferentiation,
right,
moves the liver differentiation backwards, and only afterwards actually activate the alternate pancreatic lineage in the liver.
And it was just this year that we learned that somatic cells could be differentiated. Is that right? And so this is expanding on that. With so many groups working on this, what are your next steps? When do you see this going forward, and how?
Well, we think it is a pretty safe procedure, but we still have to really prove that it is safe. So what we are doing is a lot of toxicology studies to show that the cells that we are using are just producing insulin and processing it and secrete it in a glucose-regulated manner. This we showed already. But we have to show that none of the cells remain in an undifferentiated state, for instance.
Why is that?
Because you don't want them back into embryonic stage, where you can have uncontrolled proliferation or stuff like that. Our preliminary data show that this doesn't happen because we implanted our human tissue that was converted into pancreas in immune deficient mice.
I see.
And it corrected diabetes and it did not proliferate. So we are very happy about that. But I think we still have to work on that. And the ultimate product will be that the diabetic patient will come into the clinic, donate a liver biopsy, will come back in 4 weeks or 3 weeks, and will receive his own cells now functioning as insulin-producing cells.
That's extremely exciting work, and thank you so much for joining us, Sarah. We appreciate you taking the time. All of the speakers in our webcast series are also presenters at the Cambridge Health Tech Institute conferences, and you can learn more about that at healthtech.com. Thank you.